Hi guys, this is Sai Kumar Kurtiwada. In this video, we will learn about Redux Saga and we'll learn how to configure and how to install our Redux Saga and what are the advantages of Redux Saga. So in this video, we will cover all these topics. How to install and configure Redux Saga into our store, and what does the motivation for this Redux Saga, how to dispatch Saga action from UI, how to dispatch reducer actions from Saga, how to call an API using Saga file, and what are the advantages of using Redux Saga instead of Redux thunk. For this, to understand, let me go into Visual Studio Code. I have explained about Redux thunk and how to use them in my previous video. Please watch that for better understanding. Let me switch into another terminal and let's install some dependencies for Redux Saga. So let me install a Redux npm install. We need Redux as well as React-Redux and then Redux-Saga. So this is our installation command. Let me hit this. So it will install three packages, that is Redux, React Redux as well as Redux Saga. So we are done with the installation. So now what we can do is we have to configure this with our store. Let me go into app.tsx. You can see here we have a default application, and now what I want to do here is I'll create one folder called as store folder. Let me hit enter, and inside this store folder let me create a file called as store.ts, and inside this store.ts let me create our store. So how to create a store? Already we know that we can create our store by using our store module from create store, and then let me use it from Redux, and inside this Redux we have something called as reducers. So need to pass the reducers. Let me create a folder called as to-dos, and inside this to-dos let me create a file called as to-dos.reducer.ts. Already we know how to create the reducer. Reducer is a normal function which is an arrow function over here. So that naming is to-dos reducer, and this reducer I just want to give it as a function, and inside this function let me give two parameters. One is a state parameter and the next one is action parameter. Now this state parameter I can give some set of state. For now I am giving as any, and let me give this also as any. Let me write the interfaces a bit later. So now let me create a switch case, and inside this switch case I am getting an action.type. So we need to have an action types defined over here. So that is with the cases. So first case is something related to request loading. This is my first case, and then let me go with a small letter of case, and then let me create one more case over here, and next one is here, and let me give this as success case and then a failure case. If you want, you can create them independently as an action creators. So now I'm creating as a hard-coded cases over here. Now let me create a interface for us. So the interface will always depend on what the data we are getting over, but here I'll just give the initial state for to-dos, and that is having a loading indicator, and that loading indicator is always a boolean type, and then this is not equal to, just you can use a flower brace, and we have something called as a data that may be any, and we will be getting array of data over here, and then we'll be using a error where it is of type string. Now this is my interface. Let me use this interface over here, and let me create an interface for our actions. So interface, let me create I action, which is of type where the type is always a string, and we have a payload inside this action, but let me keep this payload as any, because we don't know whether we will be sending array or a number or a string or an object. So let me give it as optional because we may not send this also. Now this one I'll just rename it to I initial state, and let me pass this over here. Now let me create an initial state for us. So let me create a const initial state which is of type initial state. So I initial state, and this will contain a loading width of false, and let me create a data where it is equivalent to our null case or empty array if you want, and let me create an error where it is empty string, and this is equal to. So now we got a data as null. So we can give a type as null, or just you can use something like array, empty array. So you can use either like this. So it's up to us whether we will be using a initial value as null or data. For now, I'll just go with null case. So let me save this. Now we got the initial state. Let me assign this state with our initial value. Save this. Now we got a state and we have assigned that state to our state variable of your reducer. And let me give this iAction over here. So this iAction will have action.type. And now whenever there is a loading case, then we have to return a state. That means previous state comma loading as, let me copy this, just paste over here and make that loading as true. And I don't want to send any of the data because it's a loading phase. And let me copy the same and put it over here. We'll be getting the state, but this time the loading should be false because it is a success case, and we will be getting some data from our action.payload and send that to the data. Let me copy the same thing, and if it is failed, then we will be getting something went wrong or just action.payload, but this time this action.payload will be a string value. Here we'll be having an array of data. So let me remove this and make it as null because it is a failure case. Let me save this. Now we are ready with our reducer, that is to-dos reducer. Let me go here. Now we can pass this reducer directly over here, or we need to pass this reducer in an other fashion. So how to do that? So we can do by using combine reducer, because in the future we may be getting lot of reducers over here. So let's create a combine reducer. So combined reducer equal to, I need to pass a combine reducers of, and let me pass an object, and we need to give the reducer name over here. So I'll give to-dos reducer, and let me point to this to-dos reducer and just import it. Now let me pass this combined reducer to this. So save this. Now we are creating a store like this, and as this is a TypeScript, we may need a root store where we are getting the state and the type of the state. So for that sake, let me export a type of root state that is equal to our return type of what is the type of our state. So we'll be getting root store dot get state. This is our type. So now we will be giving this root state, so that whenever you are using this root state type, I can use this get state from this reducers. So let me save this. Now we created our state as well. So till here we have configured only our store part, but to use this reducer in our UI, we have to configure this with a index.tsx file, where we will be getting a provider from React Redux, and this provider will receive a prop called as store. So here we need to give our store, which is pointing to our root store. So this is my root store. Let me copy this and put it over here and import it, so that this provider will receive the store and will inject to all the components which are below this. That means all the app component. Inside the app component, we may be having n number of components. All that components can receive the store values. So let me format this. Now let me go into app.ts, and here let me remove everything, and this one also, and also let me remove this logo which is not used for us. And now let me create a div, and inside this div I need to have to-dos. So for that sake, let me create a new folder called as views, and inside this views let me create a file called as todos.component.tsx and hit enter. Now we have created a to-dos component. Now let me use a snippet rfce, and this snippet will create a to-dos component. So for that sake, let me use this as to-dos component and copy this and put it over here as well as here. So let me save this and use this to-dos component inside our app component like this, and save this. Now we have one reducer, one component, and also one store. Now we have created all the related stuff for our store, but let me go into our to-dos component, and here let me create a button. And what this button should do is get remote API data. So when the user clicks on this button, I need to get the data from our API. So whenever we are getting that API, we need to get all the cases. For example, we need to have a loading case. So let me create that loading case. Const loading UI is equal to, let me use an arrow function, and inside this arrow function let me return a paragraph, and that paragraph contains loading dot dot dot, and I need one more UI called as error UI. So you will be having three phases to show in the UI, that is error UI, loading UI, as well as data. So now I'll be getting error UI. So whenever there is an error UI, I need to show here an error. So let me save this. Now we have created our error UI with a static error, and also we need original data. So const data UI. When we get the data from the backend, then we have to show this data UI. So now this data UI should have some set of table. Let me use a table, and inside this table we will be getting a lot of content, but to showcase them in a proper fashion, let me go into index.html. So here we didn't use any bootstrap, so let me plug in the bootstrap CDN. Bootstrap 5. Let me go into bootstrap 5 and get the CDN. This is a CDN for the CSS. Let me copy this and put it over here inside your head. Save this and format. Now you have a chance to use bootstrap 5, and now inside your bootstrap 5, let me go into a table, and here is the table content. So let me copy a sample table over here, and let me remove this, put it over here. But if you remember, there is a class, but if you see there is a class and we don't want this tr, let me remove this tr, and here we got a class, but we cannot use a class in React. Instead, we have to use a class name for CSS classes. So now this will be a CSS class, and let me use a striped CSS. So let me go to the striped rows, and here you have a class name called as striped. So let me copy this striped and put it over here. Now you have a table UI as well. Let me format this and just showcase this on your UI for now. So let me use a div, and inside this div, let me call this table UI. So that is equivalent to our data UI, and it's a function, so call it. Let me save this and go down. Now let me go and see the output. So you will be getting an output with the data. Let me reload. Nothing happened over here. Let's see what's the problem. Let me go into inspect and console. The slice reducer for key to do reducer returned undefined. Why? Because if you see your to-dos, we have returned when there is a case, but we need to return a default case because these actions should be triggered. But if there is no action triggered, then we have to return our original state itself. Let me save this and now go here and just clear it off, reload. Now you got the table, but this table is a static data, but instead what we need to do is we need to get this data from our store when the API is called. In my previous videos, I have explained the same thing by using thunk, but here we want to use Redux Saga. So let's understand the motivation behind the Redux Saga. So Redux Saga is completely based on the generator functions. So what is meant by generator functions, I have explained completely in my JavaScript course. I'll just provide the link in the description. Please watch that so that you will be very clear for using generator functions in our Saga. So here I'll just give a glance about generator functions. Generator functions are the functions which can be resumed or paused at any time. That means you can pause the function execution and you can resume whenever you want. So that is the pattern for your generator functions. In the normal functions, once you start the invocation of that function, it starts and executes till the end. But here it's not the case. You can stop anywhere and you can start anywhere. So inside this store, I'll just create a new folder called as Saga. And inside this Saga, let me create a root Saga file, root saga.ts. And inside this root Saga, let me export a Saga file. That means export function, and the function contains a star, and let me make this as root Saga, and inside this I need to return some set of yield functions. So what is an yield? Yield can be used for stopping your execution, and it can be used only on the generator functions. Let me zoom in a bit, and now you are getting an yield. So you have to return an yield with some of the utilities provided by Redux Saga. One of the utility is you can use takeEvery, which is an effect given by your Redux Saga. Let me import this by using takeEvery from Redux Saga /fx, and this is the one which can take an action, and that action can be dispatched whenever you are hitting this takeEvery. For example, now I want to point this takeEvery for one of the action. So let me create one action over here. The action is fetch users, and let me use an underscore, and it will have a second parameter called as callback function. So inside this callback function, let me write a console.log of I am inside fetch users. So whenever we dispatch some set of action, if that action exists in your Saga, then that particular callback will be executed. So this is our case. Let me save this and let me see yield expression implicitly results as an any. So let me use a function type as any and save this. Okay. Now we are yielding this particular takeEvery. Whenever there is a dispatch action triggered with this fetch users, then this takeEvery will be triggered, and that will call our callback function. So this is a sample takeEvery utility. We have n number of utilities in our Redux Saga, and we will use each of them and we'll understand what exactly they mean. So here we are using takeEvery, and we need to attach this root saga for our store. So let me go into our store.ts, and here we have something called as apply middleware. And for this apply middleware, we need to pass our Saga related stuff. So for that sake, let me go here and create our Saga config. And we have to create a Saga dash create. Let me import this from Redux Saga, and that is nothing but create Saga config. So I'm giving a create Saga config over here, and just copy this, put it over here and pass it like this. Now let me pass this Saga configuration to our apply middleware. Now I have passed our Saga configuration, no issues found. So now our Saga configuration is ready. But to run all our Sagas, we need to call this generator function. To call this generator function, Saga has one more thing called as a run. Saga config dot run. There is a run method which will accept our root saga, and hit enter. It is imported. Now whenever we hit or whenever we dispatch this fetch users, this console will be printed. Let's see that as a first instance. Let me go here to your UI, that is to dos, inside views, and let me dispatch something over here. So let me have a const dispatch. I'm using hooks, that is useDispatch, and let me bit zoom out. Yeah, you will be getting this dispatch, and this dispatch is used to dispatch your set of actions. So here I'll just minimize this, and we have a button. On the button, click on click. I just want to dispatch some set of action over here. Dispatch, I already have the dispatch, and inside this dispatch, let me pass a type, and the type is equivalent to fetch users. Now I am not dispatching the actions which are created in the reducer. I am dispatching an action which is related to our Saga. So this is an action. Let me save this. When the user clicks on this dispatch, this fetch users will be called, and it will search in the Saga whether do we have any dispatch event with this particular action or not. So whenever there is a takeEvery, that comes under the action, and this action will receive fetch users, and whenever this fetch user is dispatched, it will call this console. Let's see here. Let me go here and click this. You can see I am inside the fetch users inside the root Saga. But if you see this, we are having lot of content over here. We may be writing lot of logics like calling an API and all the stuff. So handling all the Saga related stuff over here is bit tricky part. So for that sake, what we'll do is we'll create a Saga file for our to-dos, todos.saga.ts, so that you can segregate them as we expect. So export, this is something related to to-dos. So I can create a function, and the function is with a star so that it indicates a generator functions. And here I am creating to-dos Saga, and I am returning a type of any. Inside this, I can just use a return statement, and I can yield my Saga, that is takeEvery. So let me copy this cut this and paste over here. So take every and just import it. So you are not able to see this import. So that's why let me write it manually. Import and take every from Redux Saga /fx. So these are something like utilities which are given by fx of Redux Saga. And now this take every is already returned by this to do saga. So let me go here, and instead of using all this code, I'll just replace this with this. And so now I'm trying to yield this to do saga. That means it is yielding this particular saga. So no need to write anything related to the return. So let me save this and let's try it out. Now again the same logic, let me click on remote. Now you are able to see, but this time we are able to see inside our to do saga. So let me zoom it. Now we have a callback function for this. Instead of writing whole callback here, I'll create a separate function for this. Again that should be a generator function. So let me go here and create a function called as to do's or saga callback. So I'm using a saga callback, and what it should return, I'll just write over here, and it's a normal function, so no need to use arrow function, and it should return any. For now I'm just using any, and inside this any I just want to see whether this callback is called or not. Okay, so let me copy this and put it over here, and now let me call this saga. So go here and just use this saga, but just check this. Okay, so we don't have any yield, so it is just showing a warning over here. Now let me write some yield keyword, but not doing anything. Let me save this and click on this. Now you are able to see I'm inside fetch user. So here it is calling. That means we have created a callback for our take every. We'll discuss more about take every in the last. So now we are able to come here, but what this has to do, this has to call an API. So let me create a function get API data, and let me create some function over here. Let me treat this as async function so that I can use Axios. So let me go and install our Axios package over here. npm install Axios. For an API call, I'm installing this Axios package. Now inside this I'll just use const data is equal to, I want to go with await and Axios. Let me get that Axios, import Axios from Axios. So Axios dot get call, and this has to return you some data from our API. Let me go into JSON placeholder, and here we have something called as users or anything. So we'll go with to do's. Let me copy this to do's and let me post here. You are getting all the data like this. So let me copy this URL and use it over here. So it will wait until this execution is done, and then you will be getting the data. Let me return that as data.data because we'll be getting all the data in a response format. So let me use this as a response to avoid the confusion. Copy this and put it over here so that this get API need to be called from our callback function. So how to call this API? Actually speaking, in the functions like generator functions, you have to call only the generator functions, but we want to call this normal functions, and that too it's an API call which is in asynchronous format. So to do that, I can use an yield where I'll be using a utility from our Saga FX, that is call. Call is a utility which is given by Saga, and that helps us to call any other function other than generator functions. So here this is not a generator function. Copy this and put it over here. So it will call this and it will yield. Why it is yielding? Because it is waiting until you get the response from it. So let me clear this off and let me assign const result. So whatever the result we are returning from here, that can be captured over here. Let me copy this and console.log of result. So you will be getting the result from your Saga API call. Let me go here and just go here, clear it off. Let's see the console or network call. Let me go and make it as no throttling and just click on this. Now API call is called, and go to your console. You got whole data in your console. Now we got the data, but where it has to go? It has to go into UI. But to go into the UI, we have to update our reducer. So how to update our reducer logic? Now we cannot use a dispatch callback function Instead, we'll use something called as utility, which is provided by fx, that is called as put. So whenever you want to dispatch something from your Saga functions, then you can use put. So this is my put, which will take a type as an action like type, and the type is we already created in our reducers. Go to the reducer, and this is success callback. If it is success, then I have to send my payload, and the payload is result. Now let me save this, and also you will be getting the response in this format. For example, if something goes wrong here, so I just want to use try and a catch. Let me cut this and put it over here, and let me write a catch where I want to return a function, and this catch will receive an error. So I want to return that error. So how to return that error? We can return something went wrong, or just I'll return something called as data colon null, and then I'll return a message where the message is something went wrong. So whenever the API fails, it will come into the catch and it will return this data. So whenever it is returning as a new data, we will be capturing over here. But if you see, this return statement and this return statements are quietly opposite. So instead of doing that, what I'll just do is I'll pass this, but here the data is response.data and the message will be null. So that indicates when the data is null, you have a failure. So let me go here, and that will be returned to your callback, and that will be stored in your result. So let me write one if condition. If my result dot data exists, then it is success. So let me cut this and put it over here. So it is success. Else you will not get the data. When you don't get the data, let me copy this, put it over here, but this is a failure case. For failure case, we already have an action in our reducer, that is request failure. Copy this request failure, pass here, and I am passing something went wrong. Save this. Whenever this Saga callback is called, I need to call my loading also. So let me copy this, put it over here. This time my dispatch is something related to loading, and the payload is not needed for us. So this gives us a yield of put, and this is something like once it is successful, we are sending the data to your reducers. So let me go into this, and let's write a console inside our loading, and save this. See here, let me go and hit this. You are able to see 200 inside your to do Saga result, but this is not getting dispatched. Why? Let's go here and check that dispatch problem. So I can yield this and yield all the puts so that it will wait until one after the other is done. Let me go here and go to your network, clear this off, and console, clear this off. Let me hit this. So it went to loading, and then it went to 200, that is to do Saga. That means even it is going for remaining stuff. If you console this after success, it will go into loading, and then it will go into success part. So let me go here, let me reload once and check it out. Click this. So you can see loading and the success is done. So now your Saga is up to date. And if there is some failure, then it will go into our failure case. Let's check that as well, failure case, and save this. Now go here, just to make it failure, let me make the URL as to do, not the to do's, so that it will be 404 error, and you have to get that 404 error into your failure case. Loading, and it failed, and it went to failure case. Now we are good to go with our UI. Now we have created all our sagas, and then it is going into our reducer and getting the data from the reducer. So let me create our selectors. Here I can create either one selector or two selectors. We have discussed about the selectors in my previous video. Please watch that for better understanding. Now I'll go with to do's export const to do's data, or just go with to do selector, and this selector is a function which will receive a state, that is your root state, and which implies our state dot to do's reducer dot data and everything. So let me send it as whole object. So let me give it as I initial state. So that is of type initial state, so that you will be getting all the values inside your to-do selector. Let me copy this selector and use it in our UI. So go to the to-dos component TSX, and here let me get that values as a destructure way. So let me use selector, and inside this use selector let me pass to-do selector. Now it will be giving us three parameters. One is data, one is error, one is loading. So whenever we have a loading, we have to show loading UI. So let me go here and let me remove this and write some conditions. If it is loading, then I need to get loading UI. If it is error, then I need to get an error UI. Else, if it is having some set of data, then I need to get a data UI. But all these are the functions. Let me call them, and then this one, save this. So if it is nothing, that means none of these parameters are came back, then show the empty UI. So this is just like a fallback. So now let me format this. But instead of this error, we have to show the error message. So let me write error over here, and let me close this. Here we have all the set of parameters. Let me go here into the JSON placeholder. You are getting a ID, title, and completed. Let me copy this ID, put it over here, and let me copy this title, put it over here, and we have something called as completed. Let me copy and paste here. So let me make it as capital I, capital T, and capital C. Let me save this. Now instead of showing all the TRs statically, we need to get it from dynamic. So for that sake, let me use a data, and inside this data it's an array. So let me use a map dot, or map will be looped, so you'll be getting an object, and let me pass here. So you are getting an object. Inside that object we need to loop the TR. Let me loop the TR, and we have an object. So let me use obj.id. So key is equal to obj.id, because if you see here, id is unique part, and we have to return this UI. So let me cut this and put it over here and format this. Go here and just remove this. Let me put this tr inside this and format. Right. So now you are getting an object, and inside that object we'll be getting all the values, something like object.id and object.title, and we'll be getting a completed. But for completed we are getting true false. So instead of showing the true false, I'll just use object.completed and go here, just copy this key and paste here. If it is completed, then I can say inactive, else active, and save this. Now we are just looping it and showing the UI, but this row I just want to use our index value, index, and let me use this as index plus 1. Save this. Now go here and go to the UI. Now let me click on this loading, and you got something went wrong because it is a failure case. Let me go into our success case. How to do that? We have to change our URL to to-dos and save this. If you see here, let me click on this. Now you got some error handling problem, typing error, data.map is not a function at data UI. So let's see what's the problem here. So let me see what we are getting that data. Actually speaking, the data, whatever we are getting over here, it's a result. So are we sending the result? Yes, we are sending the result, and that result is passed to your UI. So let's check whether it is passed properly or not. Let me check my action.payload and save this. Go here, click this, and you are getting whole object. That means you are not getting whole value, you are getting whole object. So for that sake, let me pass result in a format of result.data. It's mistake from my side where we are putting it. So whenever we put the data, we need to put whole data over here. Let me go here and just click on this. Now you got all the data over here, and let me go here and make it a slow process. Go and change it to slow 3G, and let me try to hit it again. Now it is loading. You got the data, and if it fails, already we saw that we will be getting an error. Let me go here and change this Saga file with removal of S, and let me click on reload. But before that, no thread hurling and reload. Now let me go into slow 3G, click this. Now you have loading, and now we'll be getting something went wrong. But as per our React standards, we are just writing our UI and rendering them. But to memoize this, so to use in a proper manner, we will use some sort of use memo, which will memoize, and it will not re-render again and again until it is required for us, and the value is depending on our data. So let me put this data over here, and in the same way we are returning a UI for error. So let me use memo, and let me create a dependency for this, and this dependency will have error dependency. Here we are using a static, so let me use memo, but this is not dependent on any value, so we can use empty array. So use memo will help us to memoize our UI, and whenever you are using a use memo, we should not call them, we should refer them. So no need to call here, we can just refer them. Whenever there is a update on the data, then only these will be rendered. Whenever there is an update on the error, then only this will be getting updated, so that our UI will be memoized. So let me reload this and click on this, the behavior will be same. Now we spoke about all these things with thunk as well, but what are the advantages of using this Saga? But before going to the advantages, let's understand or summarize our Saga concepts. So what I did, I created my store and I have configured my Saga with the root Saga, and this root Saga is having one yield function. For example, you may be having not only one Saga function, we may be having n number of Saga functions. In that case, what we can do is, instead of yielding one particular Saga function, you can yield all, which will take an array of properties, and inside that array of properties we can pass our to-do Saga. So here this is one more utility provided by our Saga, Redux Saga /fx. So what this does is, it will take all, which will use for combining all the sagas to create one Saga. Same like combine reducer. What we are doing in the combine reducer, we are combining all the reducers. In the same way, if you want to combine all the different types of sagas, then you can use all. So let me brief about some of the effects. All, use it to combine all the Saga functions. This is one thing. And takeEvery. So takeEvery will be considering all the API or action calls. Let me explain about takeEvery. What this takeEvery will do is, for example, you have a button where you are dispatching two actions at a time with the same action, like you are clicking 2 times the same action. This takeEvery will consider all the action calls. It will not cancel the previous calls. It will continue to have both the calls at once. For example, if you see here, I am clicking this in a fractions of second, then it is taking 2 calls. But there is one more thing called as takeLatest, which will cancel the previous action if it is in pending state, and then it will call the new one. Let me consider only the latest action instead of all actions. So whenever there is a pending action, it will cancel the previous pending action and it will take the latest pending action if both the actions are same. And there is something called as put. This is used to dispatch. It is same like dispatch. So whenever we are passing an action into this put, it will search reducers in Saga. And whenever we want to call an API, we have a call method used for async calls. So we can make some set of asynchronous API calls by using a call method which is given by Redux Saga FX. So now how this actually flows. Whenever you dispatch some action in the UI dispatches some action, then it will search in Saga first. Then it will execute Saga function if action exists. Else it search in reducers. So this is the pattern we generally go. So whenever you dispatch some set of action, it just first target for the Saga. If Saga exists, then it will execute the Saga function, else it will go and search in the reducers. If it finds in the reducer with that action, then it will execute the reducer action. So that is how you can use your Saga in your application. So we have targeted only one Saga, but we can target n number of Sagas and configure them in all effect of Redux Saga. So this is about Saga and why we need to use Saga and what are the advantages of using Saga as we have Redux Thunk. let me go here, and here you can see advantages. So if you see the Redux thunk, the control flow is very hard for us. Okay, so that means movement of things from UI to reducer we need to understand in a clear fashion. And there is one more problem in Redux thunks, that is callback hell. There may be a chances of creating a callback hell when you have the complex API calls or dependent API calls. In that case, Redux Saga helps us a lot. And whenever you are writing something in Redux Saga, it is easy to test. That means we can write easy unit testing in our Redux Saga compared to thunk. And coming to modularity means it is very easy to understand. If you see here, we have all the functions separated, and that functions already have some set of utilities, and as per them it is just going in a sequence. And also we can pause and resume whenever we want. So that is about modularity of Redux Saga. In modularity perspective, Redux Saga is better than Redux thunk. And it is very easy to debug, and we can find the solutions very easily in our Redux Saga, not in Redux thunk. And the last one is support for complex scenario. When you compare with the complex scenarios, Redux Saga may not give more performance compared to thunk. This is one of the disadvantages. But when you don't have very big complex logics, and if you want to handle the complex logics in a proper way, then Redux Saga is also good, but comparatively it is not that much high compared to Redux thunk. So that is about your Redux Saga advantages. And it always depends on the project whether to use Redux Saga or Redux thunk. So it is not always recommended to use Redux Saga. It is always not recommended to use Redux thunk. So it depends on the project and the level of architecture, whatever we are doing over the project. But as a React is an ecosystem, we can inject either Redux thunk or Redux Saga or both together. Even we can inject thunk and Saga in a same project, and we can use as per our understanding. As a personal suggestion, I love Redux Saga compared to Redux thunk, because Redux thunk is a plain JavaScript pattern, whereas Redux Saga will use a generator functions pattern of JavaScript. So in this case, I love Redux Saga just because of one reason, that is modularity. There is a sequential execution, and there is a proper understanding whenever you are working with Redux Saga compared to Redux thunk. Redux Saga is very clear to understand because it provided all the utilities to us, and we can use whenever it is required. That's about Redux Saga. And also, if you have any doubts or if you want to explore more on Redux Saga, please let me know in the comments so that I'll try to do some set of videos for you guys. Hope you like my explanation. If you like my video, like, share, subscribe to my channel for more updates. Signing off. Thank you.